Today I want to share a paper. Its name HarmonRank, ranking aligned multiple objective ensemble for living live streaming in commerce recommendation. This is written by Kuaishou. This paper just a new framework for multiple objective ensemble. This article suggests two methods to resolve traditional methods problems. Two problems. One problem, they don't align multiple objects. In fact, objects have reliance on other objectives, such as purchase is related to common. But nowadays, the methods ignore this reliance, which leads to disbalance. The second problem is that the methods to wanted is targeted to optimize the loss, but it's not targeted to optimize AUS. It's not aligned and lead to underperformance. So this paper suggests two methods. One is align multiple objects. The second is align the objective to EUC. We look at the framework. Firstly, we look at the multiple objects align. It is to align the multiple objects and get finally get only a score, which is ensemble the multiple objectives, and we can use this final score to rank the items. It use two modules to get 3 scores. Firstly, it's relation aware module. It just to predict multiple scores. And firstly, he used self-attention and then cross the attention. Lastly, they get a scalar score. The X is rated by the final scores, multiple scores, like buy, comment, follow, long way, like. They are all scalar scores. These scholars and budgeted to and through embedding layer, and lastly get the embed. And the embedding sequence is the X. The X are transformed by three matrices and then get to Q key V. And then it is transformed by self-attention procedures. And last it get the metric, the embedding sequence of the same shape. At last we get the attention embedding sequence, and then we use a query. It consists by user feature and context feature, and key and value are the previous output. We have Q key V, and then we can do cross attention. And lastly, we can get a scalar score. The reason why we use user feature as query, it is that we want to use combine user features and achieve personalizes. For every sample, we just get a scalar score as 1. By contrast, it also implement relation agnostic module. It concludes to different implement. One implement is like EPNet, and the last it also get a scalar score S2. Thirdly, it use a linear transformation layer and got S3. We added the S1, S2, S3 and get S. We use the S as the to rank the items. The second module is to align objectives. we all restruct EUC, and use EUC is our goal. It's two steps. One step is restructure EUC. The steps we can struct a batch use the EUC was a batch. It can struct to a rank vector to and the truth labels. We know the rank vector is lag. If a batch there are three scores .5, .3, .7. Its rank vector is 2, 1, 3. The second step is because is to smooth it. Because the rank vector is not vexed and not continuous, we can't optimize it. So we can use convex optimization technique to optimize it. And then we can use neural network to optimize it. Like this, the feature 2. A. Through A/B test, it justify purchase up to 0.6%. It's a good performance. With this paper, we can get two important lessons. One, it breaks the situation, which is for a long time the optimization and the valuation have different metric. Long time we use AUC for evaluation metric, but we use pointwise such log loss entropy as neural target. These people align them. In the network, which is where only one target objective can be used. Second lesson is these people finish the work of rank. It finished in the ranking freeze, which give different objectives, and at the same assemble them. There are some problems in this paper. I think she should first tell us the objective alignment, and then tell us the inter-objective alignment. it can make it easy to read for us. That's all. Thank you.